Lesson 18, class activities for Math 107. Use the table below to answer the following questions. Find and interpret f of 60. So input, output. This represents the function f. F's inputs are t in minutes, and F's outputs are miles. So f of 60, that 60 in parentheses means it's an input into f. So I go to my input for f, and my output is 50. Now I want to evaluate f inverse of 60. Okay, so f inverse of 60. So that 60 is in parentheses, it's an input for f inverse, which means it was an output of f, because f and f inverse, the roles of input and output switch. So f inverse of 60 is saying 60 is the output of f, what was the input? So find in my output row 60, and my input was 70. All right, how would I make a table for f inverse given a table for f? Just swap the role of input and output, right? So here I have x, f of x, input, output, swap them. So my y values become x values, and my x values become y values. So using the tables, I want to state the domain and ranges for each. Okay, so the domain of f here is the set of all inputs. So it would be 1, 2, 3, 4, and 5. Okay, and the range of f would be the set of all outputs, or y values, which would be 8, 10, 12, 14, and 16. The domain of f inverse, those are all the inputs into your f inverse function. So that is 8, 10, 12, 14, 16. And the range of f inverse, those are all your outputs of f inverse, which are 1, 2, 3, 4, and 5. So inverse functions, they swap the input and the output, and that means that the domain of f is the range of f inverse, right? These two are the same. And the range of f is the domain of f inverse. All right, I want to prove or verify by using the definition of inverse functions that the two functions 3x minus 1 and x plus 1 over 3 are inverses. So I have to show two things. I have to evaluate this, and I have to evaluate this, and both of them have to come out to x. So over here, I'm going to do f of g of x. Okay, well, g of x is x plus 1 over 3. So this is really f of x plus 1 over 3. And this function notation, right, I replaced this x with an x plus 1 over 3. So you have to replace every x in the formula of f with an x plus 1 over 3. So this is 3. Then replace the x with an x plus 1 over 3, and then minus 1. So my 3's cancel, and you have x plus 1 minus 1. The 1's cancel, and you get x. That one came out. Okay, let's go the other way. G composed with f of x. Well, f of x, replace f of x with its formula, which is 3x minus 1. And then the function notation here means I replaced this x with a 3x minus 1, which means you have to replace all of the x's in the formula for g with a 3x minus 1. So I have 3x minus 1. That was replacing my x. Then I have the plus 1 and the over 3 from the formula. The minus 1 and the plus 1 cancel, and you get 3x over 3, which is x, because the 3's cancel. So we proved it. So using the notation for inverse functions, we can say, well, g is really f inverse, and f is really g inverse. So it's important that we're able to understand what inverse functions represent in application problems. So let's say p equals f of t gives the population of Greenfield as a function of time t in years since 1900. What are its inputs, outputs, and units? Okay, so its inputs are t. in years, right? And its outputs are population size in number of people. So let's say I tell you that F inverse of 1400 is 57. We want to explain what that means. So 1400, that number is in parentheses. That means that that number is my input into F inverse. It's an input for F inverse, which means that it was an output of F. So that means that 1400 is a population size. And then that 57 is a time, right? So this says the population of Greenfield was 1400 in 57 years after 1900 would be 1957. So what does the inverse function represent in general? So the inverse function takes a population size and tells you when it happened, right? So its inputs are population size and it outputs a year. Okay, if C equals F of Q gives the cost in dollars to manufacture Q lunchboxes, what are its inputs, its outputs, and its units? So that what's in parentheses is always an input. So Q is my input, and that's the number of lunchboxes. So inputs are number of lunchboxes, and it outputs a cost in dollars. So if I want to evaluate F inverse of 200 equals 40, that 200, it's in parentheses, which means it's an input of F inverse, which means it was an output of F. So that is representing a cost in dollars. So we would say for a cost of $200, you can make 40 lunchboxes. Right, because if the 200 was an output for F, then the 40 was an input, and that's a number of lunchboxes. So in general, F inverse takes a dollar amount as an input, and it outputs how many lunchboxes you can make. Scientists, excuse me, have demonstrated that if you take a narrow vertical tube and fill it partway with liquid, the height of the liquid in the tube will rise and fall based on the temperature. So suppose that we have such a tube of liquid and we have a function h where h of t is the height of the liquid in centimeters when the temperature is T degrees Fahrenheit. So h of 32 equals 1. So my inputs are T's, and T represents temperature. Okay. So 32 degrees, we have a height of 1. At 32 degrees Fahrenheit, the liquid is at a height of 1 centimeter, right? Measured in centimeters. All right, h of 212 is 10, means that at 212 degrees, the liquid is at a height of 10 centimeters. Describe the inverse function H inverse. So we're swapping the role of input and output. So now your input is going to be the height of the liquid. Inputs liquid height, and outputs the temperature. Okay. And there is a wondrous device available at any local drugstore that evaluates the inverse function H inverse, and it's called a thermometer. Right? It looks at the height of the liquid and tells you your temperature. Okay, last one here. If a cell phone battery is completely discharged and then connected to power, the charge on the battery, given as a percentage of maximum charge, depends on how long it has been charging. So for a particular cell phone, we're going to let C of t be the percent charge after the battery has been charging for t minutes. So C of 0 equals 0 means that after 0 minutes, the battery is still 0% charged, right? Because you haven't plugged it in. C of 15 equals 60 means that after 15 minutes, right? Because they told us that T was representing minutes. So 15, the number in parentheses is minutes. After 15 minutes, the battery is 60% charged. And the inverse function C inverse, it's going to take as its input a percentage, and its output will be how long you have to plug in your phone to get that charge. Inputs a percent charge, and outputs time needed to get that charge. So what information would knowing C inverse of 100 give you? So you're inputting into C inverse, its input is a percentage. So if I knew this value, the value of C inverse of 100, it would represent the time it takes to reach a 100% charge. Time needed to reach 100% charge.